We're going to learn about patterns on the periodic table, and these patterns are called trends. So the big idea of this unit is that patterns of properties are going to appear from the arrangement of electrons. I know this blank is sort of small, but try your best. So arrangement of electrons, and they give it predictive power. This means that we can make predictions on what kind of trends that the periodic table will have depending on how the elements are arranged. So in order to understand these trends, we need to lay some groundwork. So the first thing we are going to understand is the idea between protons and electrons. Protons and electrons are going to attract. So you've heard of the phrase opposites attract. This may not be the case for human beings, but it is the case for chemistry. Okay. Now, if you have the same charge like this, two negatives, they're going to do the opposite of attract, which is to repel. When you have something that repels, they're going to push each other away because they don't like each other. So they're saying, go away, I hate you. Okay. Now, out of all the forces in chemistry between attraction and repulsion, between these two, the one that is most important to us is going to be attraction. Okay, so what we're saying is that all of our trends is all dependent on this force of attraction between the nucleus, which is positive, and the electron cloud that is negative. So there is basically a love story between your protons and your electrons. Okay, and our trends are all based on this love story. Okay, so in order to understand the love story, there are two influences on this love story. And so the first one we're going to talk about is effective nuclear charge. Okay, so effective nuclear charge, the definition is how strongly the nucleus, which is positive, pulls on the electrons that are negative. And the word pull is really, really important here. Okay, you're going to think of this as like a really intense hug. So the word nuclear charge is super important. Okay, you're going to think of it as like a hug. Okay, so the protons in a nucleus have a positive charge, which attracts the negative charged electrons. So here is the love story. So the more protons there are, you can think of this as the more love that they have, it leads to more, or you can think of the word stronger, nuclear charge. Okay, and this is the pull. So it's saying that when you really, really love somebody, like your boyfriend or girlfriend or a friend, okay, the stronger you're going to give them a hug. Like it's a deep hug. You're going to like hold them very, very close. You're going to pull them in. Okay, if you don't have that many protons, where you don't have much love, then you are going to experience not that nice of a hug. You're going to have this awkward, cringy, barely touching hug. Okay, think of it like a weird side hug. Okay, so now let's summarize that idea right here. So once again, the more protons we have, okay, so think about this as the love, okay, the more nuclear charge we have. And this is the pull. Think of this as like a hug, okay? If you love somebody very much and you're giving them a really nice hug, that means you have more attraction. You love them very, very much. If you love them very, very much, then you're going to have a small radius, meaning that you are close together. Now, this love story occurs when we are talking about going across the periodic table, a row. In chemistry, we say the word period. So anytime we're going left to right, okay, these are the two words that are most important to us, protons and nuclear charge, okay? The next part of our love story here is going to be about electron distance and energy levels, okay? So the more energy levels that we have, the larger the electron distance. So exactly what does this mean? So let me show you. On the periodic table, you have these numbers on the side that tell you how many energy levels an element has. So you have 1, 2, 3, 4, 5, 6, 7. So for example, if you're in the first level, right, you have only one ring. So you have protons in the middle and you have your electrons on the outside. Do you see how they're very, very close together? So they love each other very, very much. If you're at the second energy level, you have two rings like this. Protons are still in the middle, electrons on the outside. They're still fairly close together. Okay, but they are getting further and further apart, right? Think about energy level 3, right? So 1, 2, 3, this is getting further and further apart. So if you're getting to 4, right, think about how far this becomes. So see this distance, okay, gets pretty far apart. They're very, very far apart here. So that means that the love is not very strong. It's like the phrase out of sight, out of mind. You can't really see them anymore. It's like having a long distance relationship with someone from a different school. Okay, sometimes it works, but for electrons, they never work. They always end up breaking up. They can't see each other, so they're just going to move on. So the more energy levels that we have, so the more rings that we have here, further distance, they're going to get far apart to the point where they can't really see each other anymore. So let's summarize this idea. The more energy levels that we have, so remember these rings, the further the distance. Okay, if they're out of sight, out of mind, long distance relationship between protons and electrons, they're going to get less attracted to each other. They can't see each other, so they don't really love each other anymore. Because the distance, the radius, is very, very large, meaning that they are very far apart. Okay, so this is most important when we're going up and down in columns. So let me draw that over here, okay? When you're going up and down a column, in chemistry, we call this a group. These are the things that are the most important to us: energy levels and electron distance. So this is really important going up and down the periodic table, okay?